Hi everyone. This is Vale here. Today I'll be the trainer for the session. Let me introduce about myself. So I have 16 years of experience working on different data projects. So I worked on like backend systems, big data systems, data migration projects, data platforms, big data systems. I worked on on-premises, cloud. So I worked on different systems. I worked on Hadoop systems and then MapReduce, then Spark. So I worked on AWS data engineering and then Azure data engineering also. So I'm good with Databricks, Snowflake. I've been using Python, SQL for my lot of projects. So I worked with different teams. I worked with different data platforms and worked on architecture side and worked on different kind of projects. So that's about myself. So I'll be the trainer for the AWS data engineering. And so today in the session, so we are going to discuss about so why cloud, what is cloud, why AWS, and what is data engineering, and what tools we'll be learning in the course, and then syllabus about the course, roadmap, syllabus about the courses, and projects, what project we will learn in the course. So we are going to learn, we're going to understand one by one from the today's session. Okay. So so then we will discuss about first let us start about why we need data engineering, why we need AWS. So we'll discuss about the basic thing, then we will get into the syllabus and then project. Okay, so let us start first. So why we need cloud and why we need data engineering, what is the purpose of data engineering in organizations, how it is helping organizations. So what we do regularly as a data engineer, what we do regularly. So we'll discuss about all this thing. Then we will get into the syllabus, projects, and if you have questions, then we'll discuss on the questions. Okay, this is how we are going to go. So first, let us start. So why cloud? So we have AWS, Azure, GCP, different type of popular cloud. So why cloud? So why in organizations they are using cloud? So you want to build application. So you want to build an application. That application can be web application, mobile application, or an analytical application. It can be different type of applications or a enterprise applications. So you can easily build applications on the cloud. So the applications can be different kind of applications. So it can be analytical system. It can be a like applications for mobile applications or web applications. So you can build any kind of application on the cloud. So in the cloud, they provide you different resources. They provide you a lot of resources. So you can create resources easily. So creating is called provisioning. So you can create resources easily. So in the cloud, so for example, I need a virtual machine. So I need a virtual machine. So I can go to cloud, create machines, Linux machines, Windows machines, Mac machine. I can create it easily. I need to store large amount of data. So I'm working for analytical application. So I am part of an enterprise. So I am getting lot of data. So I want to do analysis on the data. So I'm collecting all the data from different sources. I want to build analytical system. So I can easily store all this data in the cloud. So cloud provides a storage where I can collect the data from all these sources. So we are talking about millions of data. So we are not talking about like 100 records or 1000 records, right? We are talking about millions of data. So I'm collecting large amount of data and storing it in the cloud, and I can build analytics. I can build machine learning applications. I can build AI applications. So I can do lot of intelligence from the data. So data plays a major role in organization for your business to take decisions, business to collect feedback of the of their teams, business to collect feedback from the products. So your data plays a major role. Okay, so we are collecting the data, storing, and then we are going to do it. So cloud helps you for provisioning the resource, quickly building the application. So cloud helps you. Okay, in that AWS is a market leader. Okay, so AWS is a market leader because AWS is there for more than 8 to 9 years, and Azure is there, but AWS is a market leader. So let me go into. So for accessing cloud, if I have browser, I can access cloud. So I can go to my browser. I have logged into AWS. So I have logged into AWS URL. So I can see different services. So there are a lot of services. I can go here, click on all services. I can see a lot of services. So you can see like there are 200 plus services in AWS. So AWS provide 200 plus services. So let me make it bigger. So as I said, if I want to create virtual machines, I can go to EC2. So in EC2, I can go to launch instance. I can select like Linux machine, Mac machine, Windows machine. I can create 10 machine or 100 machine. So for enterprise, they don't need to have a physical machine. So they don't need to have a on-premises infrastructure. Maintaining infrastructure is it's a very complex one. So if you see 10 years back or 15 years back, in the older systems, companies were using data centers, they were using physical machines. Okay, so you can see 1980s, 1990s, companies were operating in monolithic architecture. Okay, so they were using monolithic architecture where they had physical servers and they had data centers. So on-premises data centers. So they need a team to manage this. So it's a lot of cost for organization. So they need to physically manage this infrastructure. They need to have a team to manage the application infrastructure. Now the company's enterprise, like they can focus on their business. They don't have to maintain the infrastructure. And the cloud services company will take care of maintaining your servers, maintaining your infrastructure. Okay, so in the current system, we are using cloud and we are using cloud servers. So your AWS or Azure is going to manage the infrastructure. You are just going to create the service and use this. Okay. So in the 1990s or 2000, we were using data centers and the physical servers we are using, and which was complex for companies to do. So if a company is doing banking application or they are working for retail, they're working for logistics, they don't have to focus on infrastructure. Okay, so they don't have to focus on infrastructure. They can focus only on building applications, focus on building the web applications or analytical system. So building application for their core center operations. Okay, so that is where your cloud computing helped. So in 2010, companies were building DevOps development process, and they were working on microservices architecture, and they are working on cloud platforms. So that is where the like application infrastructure got evolved. Now we are using cloud and applications are built on top of cloud. And in AWS, you can create instance like 10 machines or 100 machines, and my application can run on the server. So I can create Linux machines and run my applications. So I need a Linux machines. I can create easily Linux machine. So I need to store large amount of data. So I can go to storage. You can see storage service. I can go to S3, or I want database. I want relational database. I can go to database like RDS. Okay, so you can see here. So I've created S3. So you can see S3. S3, as I said, in my organization, I'm going to do analytics. I'm going to analyze the data. So I have multiple sources. So let us say you are working for a banking, or you're working for retail or logistics or supply chain. So you are working for a different sector. So let us say you are working for a different sector. So you are part of, okay, you are part of any other sector here. So you are part of communication, healthcare, or education, or manufacturing. So your data engineering is used in all this sector. So you are working on any of the sector, and you have multiple business group in your organization. So you have banking within your organization. there are like different teams, like sales team, marketing team, you have finance team, HR team, like that. Within the organization, you have multiple teams. So each team uses different kind of applications. So like your sales team is using Salesforce, your marketing team is using a different SaaS product, your finance team is using a different application, your planning team is using ERP or SAP, like that. Each team in your organization use different applications. Okay, so they like in organizations, so let us take any enterprise, a bigger company have 200 to 300 plus applications within the organization. So they are collecting all the data. So they are collecting all the data and storing it in a centralized place. Then they do intelligence, they do analytics, they do machine learning, because you have multiple sources. So you have 200 plus sources. So you are going to collect the data. So I have to store in a centralized place. So I can store it in S3. So S3 is a cheaper in AWS. S3 is very cheaper. So for 1 terabyte of data, they charge around $20. Okay, so for 1 terabyte of data, they charge $20. So I can create a bucket. I can store large amount of data. I can store here structured data. I can store video files, audio files, semi-structured data. So data is coming from social media. I can store images. I can store video files. I can store, or I am doing getting data, structured data from different teams like CSV format, JSON format. So I can store any type of data, and it is highly scalable. So for my organization, for doing analytics, I can store different type of data here. So that is what your AWS is providing you. So it's providing you missions, virtual missions, providing you storage of data, unlimited storage of data. So it's providing you unlimited storage of data. Or I want to store structured data. So I want to store structured data like relational data. I can go here, create MySQL. I can create SQL Server, Oracle. I can create it and like create and pay and use. So here you can see for production use case, they charge you some amount. Okay, so they charge you some amount. So some dollars here. So if I'm going to use production, they are going to provide you in load balance environment. So they are going to give you in load balance environment. So the server will run on multiple zones. So you will have a backup, you will have high availability. So that is how your AWS is providing you managed database. So they are providing you managed database, and they are helping you to create it very quickly. So by using AWS service, I can provision, I can provision any kind of service easily. Okay, so for my enterprise to build applications, to build a product, they are providing different kind of service. So we have seen like virtual machines, we have seen data storage, databases. So like that, they provide different services. For machine learning, they provide services. They like for a web application, they provide a lot of services. For business applications, for IoT, for networking, they provide service. So I want to have a separate network. Okay, so I want to create a separate network. I don't want to be in public. I want to create a network and then manage everything from the separate network. So they provide as a service. So network they provide as a service. They provide analytical layer as service. You can see analytical systems like they provide Athena, Redshift, like different analytical system. Data warehouse as a service. Data warehouse service. So AWS is providing you different services. Okay, so like the services are you can easily create it and you can share it within the teams. So in AWS, if you create the services, you have IAM. So IAM is a core service where I can go and create users. So in IAM, you can see users role permissions. So I can add all the users and give permission to the server, permission to database, permission to data. So in organizations, it's easier to manage, easier to work with multiple teams, multiple business groups. It's easier to use. So that is what your AWS is providing you. Okay, so AWS is providing different service, and in the course, we are going to look into specific AWS services which are used for data engineering. For data engineering, we use like 6 to 7 services. We are going to focus on that only. Okay, so there, even though there are 200 plus services, we are not going to look into all the services. We are going to focus on which are frequently used for AWS data engineering. That services alone we are going to learn in the course. Okay, there are a lot of services here, but we are going to focus that alone. Okay, so now so far we have seen what is cloud and why cloud and what is AWS, what service they are providing. Now let us see what is data engineering. So what is data engineering and how it helps organization and what is the purpose of data engineering? Okay, so as I said before, in in a different sector, data engineering is used, banking or retail or transportation or manufacturing or education or government or insurance, right? So any of the sector, they want to do analytics or they want to do data science, they want to do intelligence, so they want to collect the data from the like different applications and do intelligence. So for that data engineering is required. Okay, so your data engineering team acts between the producer and consumer. Okay, who are the producers here? The producers can be different teams. So your producers can be different application in your organization. It can be SAP, it can be Salesforce, it can be a database. So producers are nothing but different business group within your organization. So who are sending the data, and consumers are different teams. Like it can be analytical team, it can be a data science team, it can be different teams within your organization. So your data engineering team acts as a gateway between the producers and consumer. Okay, so what we do in data engineering, so we work on the data platform. So we have a data platform. So in the data platform, we collect the data from sources. So you can see here, the data sources are, can be ERP system, it can be CRM, Salesforce, SaaS applications, it can be OLTP system, it can be a database. So you are collecting data from different sources and storing in the centralized system into the storage area. Storage system can be data warehouse or data lake, and you are transforming the data, you are transforming into different format, so your consumers can use it. So your consumers here can be a data science team, can be a business intelligent, like a BI tools, like Power BI, QuickSight, Tableau, different visualization tools, or it can be a generative AI applications, bots, like that. Your consumers can be a different kind of data applications. So in the current scenario, all the companies has this modern data platform. So they have a modern data platform, which is centralized system, which collects the data from different sources and stores the data and process the data. Okay. So for I have different consumers. So I have different consumers. So for each of the consumer, I cannot build a data pipeline. I cannot do processing separately. So they are centralizing it. So they are having a data platform. So, and the data platform is helping you to store this data into data warehouse or data lake, and the data is transformed and used for different purpose. Okay, so the data is used for different purpose. It can be used for analytics, it can be used for machine learning, or it can be used for different reporting, different kind of operations. So this is where we are going to work as a data engineer. You may work on the ingestion layer, you may work on batch processing, streaming, or you will work on the storage layer where you store the data into data warehouse, you create tables, store the structured data, or you put like process the data, store the data, a large form of data into data lake, and you transform it and store it into a different form, so your consumers can use it. So you may work on any of this layer. You may work on ingestion layer, you may work on storage, cataloging, or processing layer. So as a data engineer, we take care of all this data platform. So we work on the data platform. So we build data pipelines. We work on ETL jobs. We work on the data like data lake, data warehouse. So we work on the storage layer here. Okay. So we do ETL. We work on the ETL system. We work on the ELT. So we work on extract, transform, load, or sometimes we do extract, load, and transform. So when you are seeing here, so in the data platform, I may extract the data, load it into data warehouse, then transform. So in the data warehouse, if I'm using Snowflake or Redshift here, I may extract the data, load it into data warehouse, and then transform. I'll do ELT here. If I'm going to do ETL, I'll store it into data lake. I will transform and then store it into data lake. Okay, so I'm doing ETL using data lake. I will do ELT using data warehouse. So you need to know what is ETL, what is ELT, how to use data warehouse, how to use data lake, and how you can build a modern data platform. So you need to know all this thing. As a data engineer, we work on all this thing. So you need to have a good understanding about all this thing. Okay. So so far we have seen what is data engineering, and in data engineering what we do. Okay, so we have seen all this thing. So in the current scenario in organization, so latest architecture, so organizations are using data mesh architecture. So what is data mesh? So each organization, so within the organization, as I said, there are different business group. You can see HR, marketing, sales, distribution, operation. So if you take a manufacturing, or if you take a retail, or if you take logistics, they have individual business group. Within each business group, they have their own data pipelines. So you can see they own data pipeline, and they have their own data products. So from all these data products, they build applications. So by using these data products, they build different kind of applications. So as I said earlier, your consumers here can be a KPA and performance indicators, or a dashboard, or business reports, or AI-driven automations, AI-driven applications, or generative AI applications. So your data products are coming from different business group, and that can be used by different consumers. Okay, so you build a data platform. So you build a data platform. The data platform you build can be in any of this business group. So you are working on this data pipeline, and you are building data platform for sales team, or marketing team, or HR team. Okay. So in the organization, you may work on data mesh architecture, or you may work on data platform directly. Okay. If it is a smaller organization, you will work directly on the data platform. You will work directly on the data platform. They are not going to have data mesh architecture. So if it is a bigger organization, then you will work on a data mesh architecture, because they have a different business group, and within the business group, they have different data products. So you are going to work on the data products. So that is how it differs. So let us see now about the course. So we have seen what is data engineering. We have seen what is a cloud. Now let us go into the course details here. So in the course, we are going to learn basics about S3, IM, RDS. So we are starting from basics, and then moving into Glue, DynamoDB, and then Athena, EMR. So we are starting on ETL. So first we are doing ETL. So we are doing ETL, building a data pipeline. And the first project, we are doing ETL. Okay, so we are extracting, transforming, and loading. We are using Glue and Spark. So we are using Spark for ETL transformations here. So Spark is a powerful system for distributed computing. So we are going to learn Spark, PySpark. We're going to use Python Spark or SQL. So if you need to have basic knowledge on SQL and basic knowledge on Python. So you don't need to have a complex knowledge. Basic knowledge is enough. So we are going to use Spark. Why Spark here? Spark natively, it supports reading and writing data to different data sources. Okay, it can easily read data from different data source and write data source, and it's a distributed computing processing, so it can do parallel processing and process large amount of data. So when you have large amount of data, you can use Spark, and Spark you can run it on Glue, Databricks, and different architecture. If you learn PySpark, you can run it on Glue, Spark, or EMR. So in the course, we are going to use Glue and EMR. Okay. So first, initially, we are going to learn Glue, EMR. We are going to learn ETL, and also we are going to use Terraform. For provisioning resources, we are going to use Terraform. Then we will learn how to build event-driven applications. So we will learn Lambda, step function. So we will build an event-driven architecture, and also we will use data warehouse. We will use Snowflake as a data warehouse. For loading the data, we are going to use data warehouse and lakehouse architecture. So in the course, Along with the data lake, we are going to learn data warehouse and lakehouse architecture. So for lakehouse architecture, in AWS, we use Iceberg. So Iceberg is used by Netflix and Apple. So if you are using Azure, if you are working on Azure cloud, you use Databricks or Fabric. So in Azure, you learn Delta Lake. For implementing Lakehouse, you use Delta Lake. In AWS, we use Iceberg. So why Iceberg? So Iceberg is a modern data warehouse and then data lake combined architecture. So Lakehouse brings in the future of data lake and data warehouse. It's the latest framework where in organization to reduce the cost of data warehouse, they use Lakehouse architecture. So in the course, we are going to use Iceberg. You will learn Iceberg, how to build using Glue, how to use Iceberg and build a Lakehouse architecture. We're going to learn. Okay, so we are going to learn about uh, first initially we are going to learn Glue, uh, ETL using Spark, and we are going to learn basics about AWS and different services used in AWS. And we are going to learn here batch processing, event driven processing initially, and then streaming processing at last. So for streaming, we are going to use Kinesis, we are going to use Firehouse, and we are going to use Snowflake streaming framework here. And also, we are going to use Terraform for building infrastructure as a code. We are going to learn Terraform here. So we are going to use Terraform for infrastructure as a code. So for creating AWS resources in real world, in the organization, we don't do it from UI. So like for example, if I have to go create a bucket, create a database, run a glue job. So if you can see here, I can go to glue, create a ETL. So create a ETL job, read data, write data. So I can do it from UI. But problem is in real world, in organization, they will not allow you to do from UI. They will ask you to write Terraform code, automation for this because they have 4 environments. They have dev, stage, QA, and prod. So you will develop infrastructure as a code. So you will do infrastructure as a code. That means you will write script and do automation. So for Glue, for RDS, for all the AWS resource, you need to know from UI also, you need to know how to do it. From infrastructure also, like you have to know it. Okay, so in the course, we are going to learn Terraform also because we will be doing it from UI and then we will do it from code so that you can easily deploy it on multiple environments. So in real world, as we do it in the organization, we can deploy it on, if I do the code, I do the code as a configuration. For example, if I can see here, you can see my script here. So I'm writing the infrastructure code. So this one, I have the resources configuration. So I have the AWS resources configuration. I can deploy it on production. I can deploy it on stage. I can deploy it on dev. Okay, I have to change some configuration. I have to change the region here. So AWS region and few configuration if I change, the same resources, I can create it on multiple regions. So that is how we do it in real world. So we are not going to do from UI. You will write a configuration using Terraform. So in Terraform, we write configurations. We are going to write JSON based configuration. So you don't need to learn Terraform advanced thing. We are not DevOps. We are a data engineer. So we need to know basic level of using Terraform. Okay. So we are going to use basic level of Terraform in the course so that I can deploy my ETL in multiple environments, dev, stage, prod. I can deploy it easily. That is why we are learning Terraform here. Okay. So we are going to use different orchestration framework. We are going to use step function and Airflow. Okay. So in the course for orchestration, so I created ETL. I created my ETL pipeline. I want to run it daily in a scheduled fashion. I want to run it multiple times in a day. So I have to run it my workflow in multiple times a day. Then I can go for Airflow or step function. So we are going to use Airflow. So you can see I can schedule my workflows and run my ETL pipelines using Airflow. So you can see that I can run this multiple times a day. I can trigger it multiple times a day or schedule it multiple times a day. So you are creating workflow and running it and scheduling it. That you can do it in Airflow or step function. So if you are using AWS, you can use step function or Airflow. So you have two options. So you can go for step function and you can do the orchestration using step function. Okay, so you can do the orchestration using step function. So you can see here I'm orchestrating, I'm starting lambda, glue, I'm triggering one by one. So I can use step function or I can use Airflow. So we have two options to do the orchestration. So your step function is a JSON based configuration. So if you are familiar with JSON, you can use step function. Or if you are familiar with Python, if you are familiar with writing Python code, you can use Airflow. So we have two options for orchestration, creating workflows and running it. So in real world, for creating workflow and monitoring and running it, so either you can use Airflow and you can monitor it, monitor the logs. You can see the logs here, see the failure. So you can use Airflow for doing it, or you can use step function for doing it. So we are going to see both in the course, how to create ETL pipeline and schedule it and monitor it by using different orchestration tools. Okay. So other than this, so you can see the roadmap here. This is what we are going to cover in the course. So now I'll go to the syllabus. I'll go to the syllabus. So you can see the syllabus here. So we are going to do this course for 2 months. So this course duration will take 2 months. The total number of days is 30 days, but we will have classes 4 days in a week. We are going to have classes Monday, Tuesday, Thursday, and Friday. So we have classes 4 days in a week. And morning batch, we are starting from Friday. From 19th, we are starting the morning batch. And evening batch, we are starting it from next week. So we are starting from next week. So we have morning batch, which is like 9 a.m. Morning batch is 9 a.m. and evening batch is 7:30. Okay. And if you see the syllabus here, as I said, we are starting with AWS basics. We are starting with IM, S3, and Boto 3. So starting with Boto 3 Terraform. Okay. So we are starting with infrastructure, building your resources, building the AWS resources, and then Spark architecture, basics about Spark, PySpark. We are starting on basics about ETL thing, creating ETL pipelines using Spark, discussing about data frame. So here you are going to build the ETL pipeline. So for building ETL pipelines, we can use local Jupyter notebook, create your transformation logic, run it locally. You can test it locally. Okay, so the advantage is you will not be charged. So if I'm going to run here, if I'm going to write my SQL, so I'm writing a lot of transformations. Here you can see I'm writing a lot of SQLs. I'm doing all the transformations. I can develop it here, run it multiple times. I'm not going to be charged. So we are going to do ETL, develop it locally, and then you will be not charged. So you can do it on the cloud also. You can go to Glue, run your ETL Spark job in the cloud, but Glue is not free. So you are going to use AWS free tier. So in AWS free tier, we have S3, Lambda, different services are free, but Glue is not free. So that is why I'll help you to set up a local environment, so local Jupyter notebook environment, where you can learn ETL Spark running locally. Okay, so you'll not be charged. So you can learn it easily, debug it on Jupyter notebook. So you will learn here and then you can deploy it here. So you can learn the basics once and we are going to work on the projects. You can deploy it here on the cloud and run it. Okay, so that is how we'll go. In the courses, you will learn it on the local and then deploy it on the cloud. Okay, so initially we will learn all this thing on local environment. Then we are starting on the cloud. You can see we are starting on Glue. We are starting on Glue catalogs, working with RDS, working with DynamoDB, and we are starting project 11. So you can see on day 11, we are starting project 1. So project 1. So let me go to the project 1. So we are doing 3 projects here, real-time projects. So you are trying to cover 3 to 4 years of experience. So real-time experience of 3 to 4 years. So we are building a real-world project. So first project. So this is the first project where we are building like we are using glue RDS S3, and it's a scenario. We are trying to build a scenario here, real world scenario. We are taking data from S3 RDS DynamoDB and doing ETL here. We are doing ETL using glue and writing it to S3 and then analyzing the data using Athena, and we are going to integrate with glue catalogs and visualize it using BA tools here. So we are going to build a uh, like a getting the raw data from different sources, building ETL and validating using Athena, and we are using glue catalog to validate the data, and we are going to use BA tools to validate this flow. Okay, so this is the first project, and here we are going to use real world data sets. So we'll mock the data and use some realistic data sets. Okay, that is how we are going to do the first project. So in the first project, we will do batch processing. We will cover ETL using glue, and we will cover here RDS, DynamoDB, glue, Athena, and glue catalog. So we are going to cover the basics of data engineering here. Okay, the first project, and we will also use Terraform here for building the resource, for building the pipeline. We will use Terraform. For orchestration, we will use Airflow and step function here. So you can use any of the thing. You can use Airflow or step function. So that is the first project. So after that, after the first project, we will go into the advanced section. So after completing the day 11, you can see after completing the first project, we are going into advanced section where we are going to getting into UI optimization. So using Spark UI optimization, advanced concept about Spark. We are going learning advanced concept. Then we are working on Lakehouse, Iceberg, implementing data warehouse feature. So we will learn data warehouse here. What is data warehouse? So what data we will store? We are going to learn dimension tables, fact tables, creating star schema. So we will learn all the data warehouse concepts, and then we will store the data into Lakehouse. Because in Lakehouse, what we are doing, we are bringing in data warehouse future to the data lake. So we will learn that here, and also we will work on Lambda, event bridge, step function here. So here we are going to use event driven approach. So we are going to use Lambda step functions, and then we are going to work on the project 2. It's an event driven pipeline. So if you see the project 2, so here again it's another scenario. It's a manufacturing scenario here, manufacturing use case scenario, where we are collecting the data from different enterprise system and we are storing it, and we are doing a medallion architecture here. So we are building a medallion architecture. We have bronze, silver, gold, and we use Snowflake and Lakehouse here. So in this architecture, we are going to use both Snowflake and like Lakehouse. So we are going to store the data into different layers, and we are going to do a event driven approach, and we are going to learn here integrating multiple AWS service. Okay, so in the first project, we learned about basics about batch processing. We learned Glue, Athena, we learned RDS, DynamoDB integration with your ETL framework. In the second project, we are learning about event driven approach. We are learning about Lambda, event driven pipelines. Here we will use SNS for notification. We will use step functions, and we will use data warehouse. We will store the data into fact tables, dimension tables. We will learn about dimensional modeling and SCD type 2. So we'll learn about data warehousing concept here in the second project. So and the third project. So before starting third project, we will go into Snowflake. We will learn about Snowflake, because for the third project, we are going to build a streaming pipeline using Snowflake. Okay, so Snowflake provides you a streaming architecture. We are going to use that. So we are going to use Snowflake as a data warehouse, and also we are going to use the advanced features of Snowflake for a streaming pipeline. So we are going to use Kinesis, we are going to use Firehouse, and we are going to build a streaming pipeline. So we are going to build a streaming pipeline. So we are going to collect the data continuously here. So the data is going to come continuously, and it is going to process through Kinesis and stored into raw form, and we will transform it. So in the Snowflake, we are going to build a streaming pipeline where we will have bronze, silver, gold. We will build a medallion architecture there, and we are going to have a raw data, process data, and cleaned data. Okay, so we are going to build a medallion architecture within the Snowflake, and we are building a streaming pipeline. So we are learning about Snowflake architecture, Snowflake staging, ingestion, basics about Snowflake, JSON processing in Snowflake, how you use JSON semi-structured data, because here we are going to take a scenario where data are coming from IoT device. The data are JSON data. You are going to get the semi-structured data. We are going to ingest the data using Kinesis, the semi-structured data. So I have to flatten, I have to transform, then I have to clean it up. So everything we are doing in a streaming pipeline. So we are doing everything in a streaming pipeline. So flattening. So we are learning about in Snowflake how to do handle JSON data, semi-structured data, then streaming pipeline, then the third project. We are working on the third project. Okay, so we are doing three projects here: batch processing, event-driven processing, and streaming processing. We are learning about data lake. We are learning about lakehouse architecture and data warehouse here. So we are learning all this thing. So you can see the tools we are learning. So we are learning Glue, S3, Lambda, IM, RDS, DynamoDB, step function, event bridge, and PySpark. So why PySpark here? So main thing is for AWS data engineering, 60 to 70%, their focus will be about your ETL thing. Okay, so they will ask about ETL and they want you to focus about using Glue and doing PySpark ETL jobs. So that is why we are learning PySpark and doing using S3, using Glue, using RDS. So that is why initially in the course, if you see the first project, we are covering all the basic scenario. Okay, so we are preparing yourself for the AWS data engineering. So we are trying to make sure that you are ready for the industrial projects here. Okay, so we are trying to bring in, you are trying to bring 3 to 4 years of experience. So by doing multiple project, you will gain 3 years of experience, 3 to 4 years of experience. And you will learn the advanced concept in the second and third project. Okay, so if you are someone in the senior role, you will learn a lot of advanced concepts architecture wise, and the project wise you are going to gain lot of experience on the performance tuning, on designing architecture, working on data warehouse, lakehouse architecture. So you are going to get a lot of experience from the second and third project here. And streaming pipeline using Kafka. So we are not going to use Kafka, we are going to use Kinesis. So we are going to use Kinesis as a messaging layer here, and we are going to process. Okay, so we are going to learn all these tools like Iceberg, Snowflake, Git. We are going to do GitHub integration here, and we are going to use Terraform for the like automation. Okay, other than that, we help you for building your resume. We review your resume, provide feedback. We provide sample resumes. We provide you interview questions. We provide you interview frequently asked interview questions and answers, and mock interview questions and answers. And also we'll help you in mock interviews. So these are the things we will be doing it. Okay. Okay, so we have covered all this thing. So like what tool we'll be using? So what tool we'll be using? So we are going to use AWS free tier and Snowflake free tier. Okay, Snowflake has a free trial. So you can see 120 days. So Snowflake you can do 120 days for free. If you sign up, you will get Snowflake for 120 days. You will have $400 credit, which is free. By using your Gmail, you can create Snowflake free tier account. Okay, and AWS, you can create your free tier account. With free tier, you will get lot of service free. Only Glue will be charged. So instead of Glue, you can run it on local. So Glue will be charged. So you can use Glue minimally. I'll tell you how to use it efficiently. All other service we are going to use free. And in the local, we will use Jupyter Notebook. We will use Docker. So we will use Docker for running Glue, for running Airflow. We will use local environment. Okay, in the local, I can run Jupyter Notebook. I can run Airflow in the local. So in the course, we are going to learn all this thing like AWS cloud environment, Snowflake, So we are going to learn all this tool. Okay, now you can ask your questions. So if you have any questions, you can ask now.
Hey Will, it's
Yeah,
on this side.
yeah,
So you were explaining about the architectures, right? For
yeah,
example, Medallion architecture and a few other, like many are new to me. Like talking about me, many are new to me, and also about the services. The iceberg, this one.
yeah.
Uh, so like, how are we going to go ahead with this? Like, are we going to go with Scratch or you know, because we are going to pay a huge amount, and I just want to know, like, if everything is going above ahead, then it'll be very difficult. So that's the reason I'm asking this question.
So we are going to start from basics. So we will start from, if you see, IM. So I'm creating IM users. I'm setting up AS3 bucket. So I'm starting with basics, and we are starting with Spark basics. So we are starting with basics, then getting into advanced level. So I'm going to set up like everything from basics and the environment, everything. I'll give the instructions and I help you for setting up. So if you have issues in local, I'm going to help you for setting up.
Okay.
Okay, and if you see the already completed courses, right? You can see here class one, we are introduction. We are going through setting up AWS services, and I share the documents. So the instruction is shared, and then the files are shared, and recording is given. So you will get the recording also, so you can follow that. And also, if you have issues, I'll be there in WhatsApp, so I'll
Hmm.
help you for setting up. So that is how it will work. Okay, so I will be starting from basics. So you need to have basic knowledge on Python and SQL. So if you have basic knowledge on Python and SQL, and cloud, I'm going to show it from beginning. So we are going to start on the cloud from basics, and the environment setup, everything I'm going to show from basics.
Okay. And regarding the Terraform, like, how is it gonna be? Are we you're going to teach us, or do we need
Yeah, I'll
any
be teaching. I'll show some basic one. So I'll start
uh
with basics, like simple one, right? For example, I'll start how to create a simple Terraform. So let me show you a simple Terraform. So you can see here, I'll start with simple one. So you can see here, I'm creating only bucket here and uploading a jar file. So this is a simple Terraform, one like few lines of code. So I'll start with this. So how can we do it? So a lot of things Terraform, we can use help of ChatGPT and then we will do it. I'll show how we will build it because Terraform, it's a configuration code. So this configuration template, we will get it from help of the documentation provided by Terraform, or we'll use help of ChatGPT and get the templates. So I'll show you how we can build it. And I'll show for installation in local, and then from basics I'm going to cover you. So in also
and
in Terraform, you don't have to get into advanced level. You need to know basic thing. For data engineering, what is required, you need to learn. So that I'm going to cover it from basics.
just one last question. So
Yeah,
whatever we are going to learn here regarding the AWS, right?
yeah.
So this will help us, to get interviews and then get selected in the interviews, right?
Correct, correct. So this course is like prepared because like I have worked on AWS for
Hmm.
last 6 to 7 years on AWS platform. So based on my experience, and I do interview for a lot of company. So based on
Hmm.
that, so in all the companies, what is required, based on that, we have prepared this course. So we know that. So these are the things which are latest in the all the organization. So based on this, we have prepared. So they will ask on this. So you need to prepare yourself on this thing. So if you are able to run this, so I'm going to run it and show. So you need to practice this. You need to try it out. So you will learn it. So if you go for interview, then you can easily explain it. So if you keep practicing it and then keep understanding this, then you can easily explain it to the interviewer and then you can attend the interviews.
Okay, thank you.
So I have a question.
Yeah,
So in the current organization, like we are using this AWS and Iceberg,
yeah.
but mostly I have seen they're using AWS CDK. So is there a specific reason we are using Terraform here to like provision resources and everything?
So you have multiple options. You can use AWS CDK also. You can use Terraform also. It's provisioning the resource. So Terraform,
Mhm.
it's like it works with all the cloud. So AWS CDK works only with AWS. Okay, so Terraform, I can use it to provision Azure. I can use provisioning GCP. I can provision any other products also. Terraform is a common one. So we are using AWS here. Okay, so it's like popular in the market, and it is used in a lot of companies. That is why we are using Terraform. The thing is, if you learn CDK, it's easier to
Mhm.
adapt to Terraform. And if you learn Terraform, it's easier to adapt to. It's nothing but template. You are going to understand in the template, and then you are going to execute it in automation fashion. So that is what you are going to. You are going to write infrastructure as a code that you can use any of the code. You can use CDK or Terraform.
Got it.
So instead of doing UI, we are going to write scripts. That script I can deploy it in multiple environments. The objective is I can write CDK also and deploy it in dev, stage, prod, different environment. I can write Terraform code also and deploy it in other environment. So that is why Terraform is very popular, because if your organization has multiple cloud or they are working with multiple things, Terraform can be easily used. That is why we are using Terraform here.
And whatever projects that we will be building during this course,
Yeah.
all of that like can be done using the free tier account, or we
Yeah,
would
it
have to
can be
buy
done.
some credits.
You
Okay.
can use free tier. The only
Mhm.
problem is glue. Glue is not free. The glue they are going to
Okay.
charge you. Okay, so glue, they charge you minimal. So if you see, right, like let me show some of these jobs just completed.
Mhm.
Okay, let me go to Cost Explorer. So I ran multiple glue jobs. I used Redshift.
Mhm.
I charge like $2 Redshift. S3 50, this is I think for entire month. I'll take for 1 day. So if you see for S3 how much is charged, Kinesis is like zero point 0.02, Glue is like
Mhm.
0.01. So that is how the charges will be like less. It's not going to be in 0.001. So that is how the Glue charges. You can see Glue, I mean USD. Okay, so your Glue charges are going to be less. Let me go into job monitor. So you can see here. So where they charge like 0.03, 0.01, like that they will charge you. Okay, so which is going to be less. Or the alternative is you can practice this locally using Jupyter Notebook. You are running Spark on local, so you can run the
Mhm.
project on local and practice it. And whenever required, you can use Glue. That is how you can minimize the charges
Okay.
without charges.
Yeah, because I don't want to like leave any service open and then we get the bills sometimes because
Yeah,
that
yeah.
happens.
I'll tell you how to delete it also. I'm going to tell you in the
Yeah.
course. The other thing is we are using Terraform. Using
Mhm.
Terraform, we will delete all the resources. So you nothing will be there. Everything will be cleaned by Terraform.
Okay, understood. And yeah, one last thing. I will mostly be opting for the morning batch. So like if we miss some lecture or if we miss some part of lecture, would there be recordings available?
Yeah, recording will be available as I showed. So you can see here. So after each of the class, the videos will
Mhm.
be uploaded and you can watch the recording. So the recording will be here. So you can and the content will be uploaded. The files will be attached. So you can watch that.
Got it.
And you will get access to this platform where you can see all the recorded sessions.
Yeah, that answers everything. Thank you.
It's Arun
Yeah.
again, the side. How
Yeah.
easy is the AWS course actually? I mean, how easy is the AWS?
To be frank, data engineering is always complex. So data
Mhm.
engineering is not simple, because data engineering is a high paid job. So and when they are paying high, it's going to be complex and it cannot be easily replaced by bots or it cannot be replaced by AI because your data engineering, it's a complex part in your organization. They have 200 plus 300 sources. So you're going to collect all the data coming from different sources, and then you are going to work with multiple teams. So you have multiple teams. You can visualize it. So how it is going to be like a difficult work. So it's a difficult work. So they are going to pay high. There is always a lot of opening will be there, and the work is going to be complex. We are not going to work on one framework here. You're going to work on multiple framework, as you see now. So normally, if you're going to learn Python, if you go into Python or Java or .NET, you learn one programming language. But with data engineering, you learn multiple things here. So that is the complexity here. But you don't have to be expert there. So even though I use multiple tools, I need to know some basic elements. If I know the basic elements, I don't have to get deeper into a lot of tools. That is the thing about data engineering. So here I'm using step function, I'm using Airflow. I don't have to get deeper into it. If I know basic thing, then I can manage with that. So we are having a lot of tools, but important tools you need to spend a lot of time, like Spark, Glue. You need to spend a lot of time. That is the core tool which you are going to use heavily. And other tools you don't have to spend a lot of time. So data engineering is a complex one, but you need to know which thing to spend a lot of time, which thing you have to become expert on that, and which thing you have to know basic thing. So you need to learn a lot of basic things around that. Like you need to know basics about data warehouse. You need to know basics about different storage systems, different databases. So that is important. So it's a architecture level. You will need to know a lot of things here because you are working with different teams. You are working with different within the organization. You are working with different business teams here. So you need to know architecture wise a lot of things here.
Okay. Okay.
Okay.
Got it. Yeah.
Any questions from anyone?
Hi. Sorry, I
Yeah.
joined a bit late.
Yeah.
Just one question I have. In terms of SQL, I'm comfortable with SQL, and in terms of Python, I'm having a basic understanding in terms of writing a general code, and also how much Python will be required for this in terms of a basic concept understanding is okay, or we need a ops concept clear as well.
Basic knowledge is enough. That means, for
Okay.
example, when working on Airflow, I may write workflow using Python. So if I show the code, right? So you
Mm-hmm.
can see a code here. I'm writing functions. I'm calling that
Yes.
function.
Yeah.
So I need to know how to call a function in Airflow. You need to know how to write functions
Mm-hmm.
using Python. So we use for Airflow, we use Python, and for Spark. So when we are working on transformation, we write some simple code.
Yeah.
So we for reading, writing. So you can see here I'm reading a data. I'm importing libraries. So I'm using Python, importing libraries, and doing reading operation, write operation. So we use data frame. We write SQL. So you can see I'm writing SQL. So I combine and do. So if you have basic knowledge, that is enough for you to do transformations here. So you are not writing algorithms. We are not writing like data structures here. You are not doing a lot of code here. We are going to write basic code, but we are going to reuse that multiple times. So the transformation, whatever we write, we are going to reuse it for multiple work.
Okay. Got it.
Okay, any questions from anyone?
I think we can stop now. I think you have answered all the questions well.
Yeah, okay, fine.
Okay, so
Uh,
thanks a lot for the session, Will. Yeah,
yeah,
you want to tell something?
no, that's fine. Yeah, that's fine.
Okay,
So
great. So we will upload the recording and it will be shared. So thanks a lot, everyone, for joining. Thank you. Take care. Bye.
thanks everyone. Bye.
Thank you all. Bye.
Thank you. Bye.